Good morning to everyone. Probability and statistics, conditional distribution. I'm I'm Vignateja from CSD C section. My topic is conditional distributions. Introduction to conditional distributions. Definition. Conditional distribution is a probability distribution of one random variable given the knowledge or information about another random variable. It describes how the distribution of one variable changes when we when we conditional on the value of another variable mathematically. The conditional distribution of a random variable y given a random variable x is denoted as p of y by x. Importance of conditional distribution. Conditional distribution are widely used in various fields, in, including statistics, machine learning, and finance. They provide insights into the relationships between variables and helps in making predictions and decisions. Conditional distributions helps us understand how the probability of an event changes based on the information we have about other events. Example 1. Suppose we have data on the heights and weights of individuals. The condition distribution of weights given height can help us understand how weight varies from individuals of different heights. It allows us to estimate the weight of a person based on their height. Example 2. In finance, conditional conditional distribution are used to model stock returns. By analyzing the condition distribution of returns give, given certain market conditions, investors can access the risk and potential rewards associated with different investment strategies. Conditional probability. Conditional probability measures the likelihood of an event occurring given that other event has already occurred or is known to have occurred. It allows us to update our probabilities or be, beliefs about an event based on new information. The conditional probability of an event A given event B is denoted as P of A by B. It is calculated by dividing the probability of both events A and B occurring of P of A union B by the probability of event B occurring P of B. Mathematically, P of A by B equals to P of A union B by P of B. Conditional probability formula. The formula conditional probability formula. The formula for calculating conditional probability is P of A by B equals to P of A union B by P of B. P of A by B represents the probability of event A given event B. P of A union B represents the probability of both events A and B occurring. P of B represents the probability of event B occurring. It is important to note that P of B should be greater than 0 to avoid division by 0. Example, let's say we have a bag with 4 red balls and 6 blue balls. We randomly draw one ball. Event A is drawing a red ball and event B is drawing a blue ball. We want to find the probability of drawing a red ball given that we have already drawn a blue ball. P of A by B equals to P of A union B by P of B. Okay, the probability of drawing A red ball and a blue ball is P of A union B equals to 0. Since it is not possible to have both red and blue in one draw, the probability of drawing a blue ball is P of B equals to 6 by 10. Therefore, P of A by B equals to 0 by 6 equals to 0. Conditional probability examples. Example 1. Suppose a survey found that 70% of people who own a smartphone also own a tablet. If we randomly select a smartphone owner, what is the probability that this person also owns a tablet? Solution: P of tablet by smartphone equals to P of tablet union smartphone by P of smartphone. P of tablet union smartphone represents the probability of owning both a tablet and a smartphone. P of smartphone represents the probability of owning a smartphone. The information gives the information gives states that 70% of smartphone owners also own a tablet. So P of tablet union smartphone equals to 0.7. The probability of owning a smartphone is not explicitly provided. Additional information or assumptions are required to calculate the condition probability accurately. Conditional distribution functions. Definition and formula. The conditional distribution functions describes the probability distribution of one random variable gives the knowledge or information about other random variable. It provides a way to model and analyze how the distribution of one variable changes when when we condition on the values of another variable. The conditional distribution functions of a random variable y given a random variable x is denoted as f of y by x. It represents the probability that y takes on a value less than or equal to y given the value of x. Mathematically, the condition distribution functions is defined as f of y by x is equal to p of y less than or equal to y by x equals to x, where x and y are specific values. Conditional distribution function examples. For example, the following two-way table shows the results of a survey that asked 100 people which sport. Here, the value of random variable is known. The person is male, but the value of other random variable is unknown. We don't know their favorite sport. To find the conditional probable distribution of sports preference among males, we would simply look at the values in the row for males and tables. Males: baseball 13, basketball 15, football 20, total 48. Females: baseball 23, basketball 16, football 13, total 52, total 36, 31, 33, 100. The conditional distribution would be calculated as males who preferred baseball 13 by 48 is equal to 0.2708. The males who preferred for basketball 15 of 48 is 0.3125. Males who preferred for football 20 by 48 is equal to 0.4161. Notice that the sums of probabilities adds up. The 1 is to 13 by 48 plus 15 by 48 plus 20 by 48 is equal to 48 by 48 is equal to 1. We can use this condition distribution to answer questions like, given that the individual in is male, what is the probability that baseball is their favorite sports? From the conditional distribution we calculate earlier, we can see that the probability is 0.2708. Thank you.